Hello, folks. I'm Mike Vizard, your moderator for today's Kubernetes at Scale session. As you can see, we have an all-star lineup, and we'll introduce all those folks shortly. First, some housekeeping notes. There'll be 4 $25 Amazon gift cards that you're all eligible for, so stay tuned to the very end to see who wins those. There's also a Q&A capability. You're going to see a questions tab sitting there on your GoToWebinar screen. Poke around, find that. You can ask a question anytime you like during this session. The session is designed to be fairly casual, so we're going to be able to take those questions as they come in. Finally, there's also an ebook that you can download. Many of the folks on this webinar contributed to that particular ebook, and we think you'll find it most interesting and helpful as you try to figure out how to manage Kubernetes at scale. Let's introduce our panelists. We have first Eric Smalley, Senior Developer Advocate for Snyk. Eric, hi.
Hi, how's it going?
All right. Then we have Chad Tripod, who's the Senior Development Engineer for Armory. Chad, say hi.
Hey, hi everybody.
All right. Sherry Itzon is the Senior Product Manager for WhiteSource. Sherry, welcome.
Hi, good morning.
All right. Then we have Aaron Newcomb, Director of Product Marketing for System.
Hey, good morning, everybody.
And finally, we have also Ravi Lockman, Evangelist for Harness.
Hey, y'all.
And David McKay, Senior Developer Advocate for Equinix Metal.
Hi there.
All right, great. Let's get started with Chad up front there, since you're, at least on my screen, front and center.
Yeah.
I think a lot of people are down the path of Kubernetes, but not everybody is equally far along. So I was wondering if you would take a minute and just set the stage and say, why would I even go down this path? Because we know it's not necessarily easy to do Kubernetes itself, and the environment itself is complicated. So Chad, why are people trying to deploy Kubernetes at scale? What is the benefit to the overall organization?
Yeah, so what I've seen in reasonings of why people are deploying Kubernetes at scale is that a lot of industries now are becoming software first industries.
Hey everyone, it's Alan Schimel. Welcome to Techstore TV for today, Monday, May 4th.
Alan.
May already.
We're seeing a lot of changes in the way that pardon that little interruption there. Basically, in the way that enterprises and companies are accessing information into consumers. So consumers now are, looking for new software. They're looking for new ways to engage. And the reason that change and that shift is important is that what we're seeing is a refactoring in applications. So we're actually seeing a lot of people taking the time to invest in microservices. And what that allows them to do is, iterate on code extremely quick. It allows them to deploy code at very large scale, and really gives the developer the ability to iterate and improve on features and functionality to engage with those customers. So that is, perhaps a reason that you would want to take that venture and onboard a platform like Kubernetes is that the gains that you get to accessing software and the end users is worth the uptick or the venture into Kubernetes. And I think that's why we're seeing a lot of customers go that route, is to get better software out to their end users.
Thanks, Chad. Sorry about that, guys. We got a little noisy there, but let's jump over to David. What are you guys seeing? I mean, you have a lot of experience in this space, so what are you seeing as the primary benefit here?
Yeah, so like Chad just said a moment ago, like the adoption of microservices, I think, is really prominent in a decision-making factor for Kubernetes. If we look at why people want to adopt cloud-native architectures and microservices, it's because as humans, we struggle to understand complex systems. Like, we want to be able to simplify the code that we're writing so that we're deploying smaller, isolated components of code that are easy to test. However, when we simplify the applications to that degree, we're not removing complexity, we're just pushing it down the stack to the infrastructure layer. And that's where a tool like Kubernetes comes in and gives you a lot of things. And I'm not going to say for free, like, it's very common to say, oh, Kubernetes gives you this for free, but you have to operate Kubernetes. But Kubernetes brings load balancing, service discovery, reconciliation, health checks, all of these things that really allow us to take the simple code that solves a human problem, writing microservices, and then Kubernetes helps us solve some of the more technical challenges around orchestrating and deploying that and making that a little bit easier on us, so that we don't have to write all of this code ourselves. And I think just that one thing, cloud native architectures and microservices, should be the primary reason, hopefully, that people are adopting Kubernetes.
Robbie, do you think this is an improvement as well? I mean, it used to be that there were all these different platforms that you had to tailor your particular deployment to. Do you think that despite the maybe hurdles we're looking at, this is a step forward?
Yeah, I really think it's a step forward. Let's take a step forward, you need to step back. Like, so looking at what the distributed system landscape looked like right before Kubernetes, let's say in Java land, as a software engineer, that march towards infrastructure starts to occur. Like, if what Kubernetes brings us is ubiquity. The points that Chad and David brought up are kind of spot on, that as a software engineer, there are application-specific operational tasks that have to occur. Like, what if there's a failure? Well, is it on your middleware stack to kind of reconstitute a node? Or you can declare in a simple YAML file, hey, here's my health check. Do this when a failure occurs. And so the most complicated part of a software engineer's job, let's say that odd bridge between application, infrastructure, and operations is being bridged with Kubernetes. Now, it's a complex system, and there's lots of different opinions in Kubernetes, but it is very ubiquitous on platform vendor to platform vendor with KADES.
Right. Hey, Aaron, do you think people underestimate what it takes to get a Kubernetes environment going? It seems like there's a lot of piece parts that go beyond just the cluster itself.
Yeah, I think that happens more often than not. It'll change over time, obviously, as people get more comfortable using the technology. It's just like any system, right? Kubernetes is still relatively new. I think it was introduced to CNCF, like 2014 or 2015, something like that. So this is not like hard drive technology that's been around for whatever 70 years or something, right? So this is still relatively new, and I think it does take some time to adapt. However, because it's open source, there's so many great resources out there for people to take advantage of, right? So I think what we're seeing is a rapid ramp up on both knowledge and number of deployments because of that change in the technology landscape. So yes, I think it is difficult for people to get their arms around it. It is very complicated, as Ravi said. But the good news is the information's out there. People can go take advantage of it, learn about Kubernetes, and deploy very quickly and get up to speed very quickly.
Chad, do you think that moving to Kubernetes kind of forces you down the DevOps path? I mean, there's a lot of people who are at different points in that journey. It's been around for 10 years, but have we reached a point now where it's an absolute requirement if you're going to do Kubernetes and microservices?
Yeah, it's definitely an option. Kubernetes isn't for every shop, but there, definitely, as Aaron mentioned, a lot of resources. There's a lot of people who are getting up to speed on the certifications. And also too, I think people now have enough time, enough run rate with it that they're starting to expand out and go from, perhaps small sets of clusters to now larger clusters, starting to operationalize it, starting to monitor it, starting to understand it a little bit better. And so that is, I think going to continue to grow and grow across a lot of companies.
Robbie, you agree with that?
Yeah, I agree with that. I think Kubernetes being kind of like the bridge between application infrastructure and operations, like there needs to be some understanding, because like the topology of the team makes sense. Like I've heard everything from we let our developers have kubectl access to they'll never touch kubectl like the command line interface to Kubernetes if they even try to. And so getting the particular people, process, technology stuff down, which DevOps brings, like it's important to do that with Kubernetes. Like Kubernetes is a tool, like everybody on the panel would agree. It's not the ultimate, let's say, automatic DevOps checkbox if you use it, but it does help you enable a lot of those philosophies in the platform.
Yeah. What exactly is the stack looking like? I mean, some people would say some of the components are more complicated than Kubernetes is these days. Things like Prometheus and things like maybe Istio, depending on how far down the path you go. David, how much of this stuff do I really need, and can I get there over time, and what's the right path towards building the stack?
That's a great question. You need it all. Like, if we talk about Kubernetes as, you know, an API for us to deploy applications to, that's really a superficial concern, right? We're providing a standard API for developers to say, hey, I want to run this thing. But it doesn't tackle the, okay, what do I do when it's unhealthy? How do I scale it? What are the rules for scaling that up? How do I scale it back down? Then you mentioned Prometheus. There's the metrics. How do I know that it's running well as well? And all of these concerns just become even more important when we start deploying to Kubernetes. Things that we could maybe take for granted on traditional deployments no longer can actually be the case. And the stack itself with Kubernetes, you say that some of the components are very complicated, then yeah, definitely. Now as an operator, I need to decide which CNI implementation do I want. And then what about stateful workload? What about CSI implementations? And then service mesh, we're bringing all of these new technologies that Kubernetes enables and giving people almost information overload to a certain degree. Like it's easy to get started. You write a deployment YAML, but the rabbit hole goes deeper and deeper. And I guess teams need to draw a line in the sand of how quickly they consume that information without overloading themselves as well. So there's a lot, and eventually I'd hope that teams and organizations are using most of the best practices, but you got to really pace that appropriately.
Let me follow up on that a little bit, because for the most part, early on, everybody was doing these stateless apps because theoretically it was simpler. And basically, all these stateless apps, as far as I can tell, at the end of the day, wind up being stateful somewhere. There's data somewhere that gets generated and it gets stored externally to a system. And now people are talking about putting the databases themselves on Kubernetes clusters and building more stateful apps on the cluster. And is that harder still? And is that something you should do later on, or do you start to see people do that earlier, or where are we on that adventure?
So I am a big advocate of saying run your stateful workloads on Kubernetes. I am not the popular vote there for sure. There's definitely a lot of really good arguments for why you shouldn't. But if we look at the way that we still run stateful applications outside of Kubernetes, they still have all the same challenges. Like we have to be able to, data has gravity. How do we move that around the infrastructure and the machines? And realistically, you can't unless you're using a cloud native or distributed database by default. But let's forget that for a moment. So if I'm running a database on a bare metal machine with data that cannot move and is stuck to that machine, then I'm just pinning it. Right? There's actually not a lot of difference between doing that in Kubernetes too. Just saying I'm going to run the stateful workloads on Kubernetes, and I'm going to pin it and hard code it to this node over here. And it'll work pretty much the same, only we get to take advantage of controller loops. We get to take advantage of health checks. We get to take advantage of all the other things that Kubernetes brings. We have service discovery now for that workload just because it's in the Kubernetes API. So I think we should at least take that first step to running our stateful applications on Kubernetes, even if we don't take advantage of floating data and CSI implementations and having ephemeral nodes. Like you can start with a really primitive approach and then build up and layer that complexity through operators and other tooling over time. So yeah, I definitely would encourage people to run stateful workloads and applications. I'm not sure how many people would agree with me, but I'm willing to stake my claim there.
Anybody in the panel fundamentally disagree, or should we stay with stateless?
Yeah. I mean, I totally get it. Like, when Kubernetes first came out, it was like the immediate split was there, like, 2014, 2015, if you have any state, you're running the state somewhere else. Like, to David's point, like, the ecosystem really evolved, like things like operators and controllers, like you're bringing in that operational focus on it. You can start to react. If you take a look at what the big problem with stateful workloads was, there needs to be an order of operations for certain things to happen, like database consensus, right? Or message broker consensus. There's an order of operations that need to occur. If there's a failure at one of those points, how do you recover for that? And Kubernetes is made for generics, right? Like those are application specific tasks that need to occur. But living in 2020, we have the operator, right? That's here for us. Now, it is difficult, not to bogart the conversation. Distributed systems principles, and David was touching on this too, like your distributed systems principles still apply, right? Like Kubernetes didn't erase it. You have latency, right? The I forget who in some microsystems, the fallacies in distributed computing, like it's super true in Kubernetes. You don't have unlimited bandwidth, there's latency, you have more than one administrator, like those are all exacerbated with K8s.
All right, Aaron, you can be the referee here. All right, Sysdig sees everything, right? So are you starting to see more stateful applications out there, or is it still the minority?
I would say it's still the minority, although, you know, things are going to have to be split for the foreseeable future, right? So it's very difficult for me to see how everything can become stateless. I think that's the goal that we all should have. That makes it, especially automation, a lot easier if you're running in that fashion. But I just don't see how we get there entirely with having these relational databases that still need to be stood up and having these data backends that aren't leaving anytime soon. I just don't see how you can migrate those over into a stateless environment without sacrificing something. And a lot of times, you know, security is the big decider, if you will, in this race, is that risk and security come in when people start thinking about how do we move these applications into completely stateless environments, because people still have to secure, especially the data that runs in those environments. It's probably their most important asset that they have. And so I think there's, whether it's true or not, I didn't say whether it was true or not, but whether it's true or not, they still feel like we have to keep some of this environment stateful.
Some of this is politics, right? Some people just want to control the workload, and they're okay if the developers run off and do a little stateless thing. But if I do stateful, I got to bring in the rest of the IT operations team, and that becomes maybe a harder conversation. Is that part of what goes on here, David?
Yeah.
Sorry.
Go ahead, David.
Yeah, I mean, I'm not a good person to talk about the security of the data, but I think there's a lot there that we can kind of break it down and talk about. But one thing I would add to this conversation about stateful workloads is that we're in a very interesting time as far as technology goes, and that the disks aren't the bottleneck anymore. The disks are actually faster than the CPUs in most of our production workloads these days. With the advent of NVMe, and especially NVMe over fabrics and over TCP, and I think we're in a very, we're at a turning point for stateful workloads on Kubernetes. I look at tools like Portworx and OpenEBS, where they have these really cool data layers that work across clusters and provide data that can move between machines relatively easy, where writes come in and are ported over NVMe over TCP. So yeah, I know there's definitely people here saying don't run stateful workloads in Kubernetes, but I think that's going to change hopefully soon.
Let me ask Eric here something on this question. Do you think that as these stateful workloads start to show up and we do see more data, that the conversation around security of Kubernetes changes or it becomes more critical to the organization? Because if it was stateless and it was storing something else, I could maybe get away with a lighter approach to security. Is that changing now?
Yeah, because as was mentioned before, the data gravity is going to change. Today, you have perimeter controls around all of this stuff. And as you move into microservices and ephemeral containers, your NAS, for instance, can no longer say this server can access this, and your database can no longer say that user at that server can access it. So absolutely.
All right. Sherry, are you seeing the same thing? What's, you know, if I do put more data on the actual cluster, does it changes the type of tools that I need, or is it just a matter of the workflow around those tools?
Yeah, of course. So it does change the tool, but it also changes the approach. So like we think of Kubernetes, you know, you have the network security. This doesn't really matter if you have any important data there. You have the workload security anyway, and now we're speaking about the infrastructure security. So it's really up to, you know, even if you're not storing any data, and we discussed like the ones that believe that Kubernetes should be completely stateless. So even if you go to that approach, you still have to secure, you know, your network, for example, your YAML files, you know, the tokens and everything. So it's really a matter of approach. Of course, in stateful applications, you have all the data, so you have to use other tools. Yeah.
Chad, do you think that there's enough skills out there? Probably not, but to the point is, do people sit there and go, I don't really have the skills to go do this, so they try to push things to their legacy approaches, their monolithic approaches, and the devil they know? Or do you think that there's a bigger appetite now because there is this interest in cloud native and a lot of this chat about digital business process transformation, and people are trying to be more relevant? And if it's the latter, just to fulfill the question, what is your advice to people on how to get started or to learn Kubernetes? Is there a place to go that is the ideal kind of launch point?
Well, yeah, I mean, for me at least, there's some really great online content that'll help you get to your certification points. You know, getting the CKID, CK are always great starts to actually, know what's there, what's available to you, and get that level of confidence inside of the platform that you can make some of those more, riskier type decisions on moving those workloads into Kubernetes. But yeah, just as as more and more people become proficient at Kubernetes, I would expect to move some of those more. It's really about risk. If you're going to move those workloads in or not, it's really kind of taking a look at the risk of making that endeavor and whether or not that's something you want to take on as as an organization or team.
So, David, the next question comes to you because do I need to up-level my skills? Do I have to get out there and figure out how to do APIs and CLIs and the full boat DevOps? Or do you think that organizations will lean back on IT administrators and give them GUI tools to manage these Kubernetes clusters and kind of, do it the way they've always done it? Or will everything, become this SRE conversation and everybody gets a new title and a raise to go with it?
Well, I think we all like raises, but I think realistically is that Kubernetes is now at a level of adoption where it's catering to almost anyone that is working with software. There are, extension points in the API where people can now start to abstract away some of those more complicated topics with their own custom resource definitions, providing simpler API surfaces for people to deploy to. Like, there's a SIG at the Kubernetes project working on an application spec to try and get rid of this idea of a deployment and a service and an ingress and just make it really trivial almost for developers to say, I want this on this cluster. But for the people that don't want to go down the more complicated route, there's also a whole world now evolving of UIs on top of Kubernetes. VMware is working on a really cool project called Octant. There's the Kubernetes dashboard itself. There are really all these different facets to consuming Kubernetes that don't necessarily force you to go down a rabbit hole of knowledge and learning all the fundamental primitives. And I think that's in part because of the maturity of the project now. We talk about Kubernetes only being 5 years old. But, in technology, things move really fast. Kubernetes is evolving very quickly. And if we just look at the size of that community and the number of open source contributors to the project, there was a joke on Twitter this week, actually. The Kubernetes Slack has so many people in it that the last time someone did an mention of channel or here, I can't remember which it was, it caused Slack downtime, trying to process all of those requests and push notifications. And that was when the community was at 30,000 strong. The Kubernetes community is now at 110,000 just in the Slack. And if you look at that as a wider lens across the world, so people that aren't actively contributing, that number is going to far surpass that. And I think the tools to make it an enabler for anyone of any experience is slowly coming to fruition. And I'm looking forward to seeing more of these tools, depending on which level of the stack you want to be at, making everyone's lives easier.
Hey, Aaron, when you guys are out there and looking at Kubernetes, how many flavors of Kubernetes do you typically see in an organization these days? I think I lost count at there's something like 100 certified distributions. I'm sure not all of them are being used equally, but what are you guys seeing from your vantage point in terms of the types of distributions that people are using? Are they standardizing on one? Are there lots, or what's going on?
I don't see a standardization among customers, although there is a desire to standardize as much as possible, right? To enable a common platform that everybody can use no matter what. When something goes wrong, you know what happens. But the ecosystem is still new, so people are trying different things out. Also, people want to run in different cloud environments, right? And that comes with various challenges about what that cloud vendor supports. Are they completely standard? What version of Kubernetes are they running? Do I want to move to a serverless environment, something like Fargate? That changes things as well. And either, tends to decrease the level of visibility that you can get if you're from an ops background, like I am. So I think I don't see a one particular standard. What happens from my experience, having done this for a while, is as soon as you develop a standard, then something goes off the rails, or there's some new development that you want to go take a look at. So for example, you acquire a company that's running, they have their own environment, and they're running either a different version of Kubernetes, or they're running in a different cloud platform, and you have to have tools that can go out and help you deal with that. It's not enough just to have a single tool for a single, environment. You're going to have a tool that spans across multiple environments to make your life easy, or easier, I should say, especially when a problem comes in.
So does that, in your mind, become an issue when people talk about Kubernetes is supposed to be the driver for this grand vision of hybrid cloud computing that we're talking about out there? It's not clear to me that most people are there. It seems like a lot of people have multiple clouds and they have different consoles for managing all that. But do you think that I need to standardize to get to that level of hybrid cloud, or can I really rely on the API at Kubernetes surfaces to have a real hybrid cloud environment, regardless of what the distribution is?
For the most part, you can rely on it. It's one of the things, as I see tools that are developed that are Kubernetes, that support Kubernetes standards, then it doesn't matter as much where you're running your workload, right? As long as it's running on Kubernetes, you're going to be able to monitor it, deploy your software, et cetera, et cetera. So I think it is a leveler when you look at where things were, even 3 or 4 years ago, where you had multiple orchestrators. Things were much more complex, and whether your tool supported it or not, the tool that you're using to either monitor or deploy, maybe you'd have to set up your environment and your deployment strategy in one way for one orchestrator versus another. Now that things have somewhat standardized on Kubernetes, it does level the playing field quite a bit, I think. And again, I think it's a reason why once that happened a few years ago, where people started saying, oh, Kubernetes is de facto standard. I mean, once that happened, then all of a sudden you're seeing a lot more tool proliferation, because people can write tools that can span multiple cloud platforms, multiple versions, and you're still able to monitor those environments or deploy in those environments in a standard way.
Okay. Is there anything different about the way people have been deploying Kubernetes? We see it with all these web startups, but I think the enterprise is a little more conservative at the very least, and somewhat more skeptical. Is there anything different about deploying Kubernetes at scale in an enterprise environment that you guys have seen? I'll start with Ravi.
Yeah, it all depends on cluster topology. So this will actually play off of what Aaron was just mentioning. So if you take a look at, let's say, if like us 6 were just on a company, like we were our own startup, we would try to pack as much workload as we can into, like, let's say, an application server. But enterprises, they have like this isolation concept, right? So they might be putting limited amounts of workloads on one Kubernetes cluster. Like, hey, this is our payment processing Kubernetes cluster. Hey, this cluster is dedicated to a specific resource. And so they're able to kind of maintain their old adage that, hey, we have one server per function. We can have one cluster per function, but now we have operational tasks such as restarts and whatnot that can come into the cluster. Versus if it was just us 6, hey, we have $100 a month, and we're going to put every single service we can on our own cluster to get density. And so that's I see that dichotomy still. The more risk, the less density. The less risk, the higher density in a cluster.
Yeah, I think the other thing I would add to that, Ravi, I mentioned security before. There's also compliance concerns that these enterprise customers have that maybe the smaller ones aren't quite there yet. They don't have to comply with as many regulations. And so from a security standpoint, there is a much greater concern, or much more risk perceived with going to any new environment, right? It doesn't have to be Kubernetes, it can be anything. We're changing our network vendor to some other vendor. Like, that is a really risky move for large enterprise. They are more risk averse, and they do have just more moving parts that they have to worry about from a compliance standpoint that maybe a smaller company doesn't. And so I think that's a big determiner for a lot of companies as to what platform they choose, what tool they use when you start getting into that enterprise level.
Yeah, I definitely agree. Oh, sorry. Yeah, I agree. I think that, you know, in Kubernetes, you have the option to deploy straight from open source and without any special configuration. And this has a vast security risk. So if you're a startup, you may go for it. You know, you will not take much of a, you know, health checks and monitoring and all this stuff that a large enterprise would take. So monitoring, logging, you may, you know, neglect that a little, as well as the security and the governance. So, you know, you have sort of in Kubernetes, there is this feeling or approach that there is a lack of built-in security. So this is why I think more and more enterprises would go to managed services other than doing it themselves, even though that the community today has great tools to implement security yourself without any managed service at all. So, you know, it's up to there is definitely a learning curve that I think enterprises are more willing to take and to go that path, and maybe, you know, smaller startups will sort of neglect this regulation and security and stuff like that.
All right, well, Sherry brought it up, so I'm going to go here, but there's a conspiracy theory that's walking around out there, and maybe David can shed some light on it, but some folks say that they basically left out the security controls in Kubernetes to make it appear simpler than it is, even though it's already pretty complex. So a lot of IT organizations wouldn't be like, oh my God, and overwhelmed, and then they figure it out later. Or did just the security stuff come along later, and it always does by definition and because of the way things are engineered?
So, yeah, go ahead.
Sorry, you go.
No, go ahead.
Yeah, I don't think there's I mean, I haven't heard the conspiracy theory that security was left out to make it easier for people to adopt. Kind of what I'm paraphrasing there. I think there's definitely been a lot of challenges with the way that the security has evolved in Kubernetes. I mean, if we look back at the first, the ABAC model for doing attribute-based authentication, you know, there was a lot of painful points there. There was a lot of lessons learned, but we were also trying to take advantage of what we were familiar with, you know, using tools like LDAP. Now that we're starting to mature and we've got the RBAC model, you know, and the Kubernetes community is continually evolving, you know, the one thing that people always talk about with security is secrets. Like, why are Kubernetes secrets called secrets when they're not secret? And we're now solving these tools through extensions and other add-ons, you know, tools like Vault, tools like Falco coming from Sysdig, you know, giving us better insights into the security concerns in our cluster. And SIG Security is actually doing a lot of really good work. With the last release, 1.19, you know, there were lots of really nice improvements to the way that seccomp works, for instance, on our workloads that enable us to have default profiles and then pull in profiles with controllers. So I don't think security was left out. I think we're just learning what those boundaries are, and they're continually evolving as we adapt. And with the number of users we have now, as the Kubernetes community, we're still getting new interesting use cases. We're still learning how people are applying it and how they expect it to work. And that's why Kubernetes releases so frequently as well. You know, we get 4 or 5 releases per year, and that's just continually iterating and evolving the API.
You guys agree with that? Eric, let's start with you. Do you think that security was overlooked, improving? Where are we in this adventure in the state of security as it relates to Kubernetes?
No, I don't think it was overlooked. I think I would echo just about everything David just said about it. I think what you see in most open source software is that security at any given enterprise is going to be different. In my background of consulting, it's very hard to generalize security because a financial institution is going to be much different than somebody who's got HIPAA compliance, or I have a lot of travel industry background, a lot of PCI related in that and things like that. What I see kind of anecdotally is a lot of not invented here syndrome happens at enterprise, where you've got, we mentioned politics earlier. I don't like to call it that, but network is just now finally loving software-defined networks, or I think they are. And now they're being told, hey, trust network policy in Calico or whatever else. those kind of sea changes are happening more often based on, and not just in Kubernetes, and open source software in general. And I think that actually, Kubernetes has done a great job of adopting security technologies quickly, in my opinion, compared to, I'm old, so the stuff we dealt with back in 2000, right?
So progress is being made. Sherry, would you agree with that? And I want to follow up on something you did say earlier, but go ahead.
Yeah, I agree. I think, not only in Kubernetes, but there is always a friction between ease of use and security. And not only in Kubernetes, we used to say that security is holding us back. So I think this is why maybe this conspiracy theory that you're talking about, there is a feeling that security holds us back. I actually think that in Kubernetes, with the community, and we discussed RBAC and secrets, I think that this was not something that was overlooked, and you have great tools for security in Kubernetes itself. Yeah.
All right, well, we don't get out as much as we used to, so conspiracy theories are abounding everywhere. But on this open source comment that you made earlier, would you download raw bits of Kubernetes, or would you always go to a curated version or a managed service version as you were describing? I mean, is that a best practice, or are you kind of, if you do download the raw bits, are you kind of insane, or what do you think?
So it really depends, it depends on the size of the company. It depends on your level of expertise. If you are an expert in Kubernetes and you did it in, your previous company and you're super familiar with it, maybe going to managed services will actually hold you back because you don't have all the options that you have when you deploy from scratch. But if you don't have time for, to actually do this learning and understanding of the platform, and you want to do sort of the bare minimum, even though you still have to understand a lot, I would maybe recommend on a managed service, even if only from the security standpoint, because when you go to managed services, usually the security standards are way higher than, just taking a Kubernetes, from scratch from open source. So this is something that I would definitely consider. Deploying workloads securely definitely requires expertise, not only in Kubernetes. So whether you're using, a Kubernetes distribution with pre-configured security controls, or if you're building it yourself, you have to make sure that you are familiar with the ins and outs of Kubernetes. So that's my point of view.
David, do you agree with that? And I'm going to also ask you to maybe explain something a little bit, but when the Kubernetes folks talk about the platform, they say it's essentially an abstraction for building higher levels of abstraction, and that it's a platform for building platforms. And yet I haven't really seen the thing that sits above Kubernetes that makes it more accessible to mere mortals just yet. So what is, how is my abstraction going to have an abstraction, and what might that look like to make the whole thing somewhat more accessible to people?
Yeah, great question. So yeah, the Kubernetes community would often say that Kubernetes is not a platform, it's a platform for building platforms. And I think that's very true. It gives you all of the components like Lego bricks, and you get to build up whatever you need and you can make it work. There are some really cool projects that do try to make it easier. One of the always pops into my head is Openshift. They are trying to make it easier from a developer point of view of how do I deploy to this Kubernetes cluster. It's still pure Kubernetes under the hood, but they're just trying to simplify things. And there's a lot of people that are taking this approach too. But yeah, it's a platform for building platforms. And trying to understand where you come in on that stack really just comes down to each unique company. I don't think there is a semantic or anyone out there that can tell you this is what level of the abstraction you need to be at when you're adopting Kubernetes. I would say depending on your use cases, most people should start with a managed service. Just go use JKE, just go use AKS or EKS. Yeah, just go use one of these cloud providers. And when we talk about the platform of platform things, there's lots of really cool tooling as well that's trying to simplify that. I don't know if anyone's familiar with Crossplane, but Crossplane is a Kubernetes controller that exposes custom resource definitions that allows you to provision AWS or Equinix Metal or Google Cloud Platform resources using Kubernetes. So now people are using Kubernetes to spin up their cloud infrastructure, which then spins up Kubernetes. Not only that, there's the cluster API project as well. So you can use Kubernetes to spin up Kubernetes. Like, we have all these different layers and possibilities, and there's no single, this is the route or the path that you need to take. It's just start with a managed service and then pick your own path going from there. Try and work out which components you need to customize. For smaller software companies that just want to scale their application, they're probably just going to want abstractions that focus on what the application is and how to scale it. People that are building their own platforms to enable developers, like DevOps teams and SREs and platform engineering teams, are probably going to go slightly lower level on that abstraction as well. So pick your own path, there's many.
Rafi, let me ask you something. Do you think that long-term, might I not see Kubernetes at all because there's going to be some platform sitting on top of it that will roll out my application and it will just fire up infrastructure as code in the form of Kubernetes, but I may never actually see the underlying thing? Or is that where we're moving towards, do you think? Or how automated can automated get?
It's the old computer science adage, like that you're just moving complexity left to right like an abacus, right? So yeah, there's definitely lots of tools out there that do that. Like to David's point, like Openshift is one of them. You know, they made the change to go towards Kubernetes before they were a Kubernetes-based project, right? And so it all depends on like where do you want to invest the knowledge. Like I would say for a majority of enterprises, I would say at least 80%, like, you know, tuning the cluster is kind of a little bit beyond what they want to do, right? Like, hey, infrastructure is becoming more generic, a cluster is more generic. The big thing, again, I'm going to jump on this, I know, a little bit long-winded answer. I like the Kubernetes Illuminati thing, the conspiracy theory. I got excited. I'm like, conspiracy theories, yes. But let's talk about security really quickly and why it's such a challenging problem and why you need even any sort of vendor help. So Eric brought up actually a very good point about a half hour ago. I was thinking about it. It's all about perimeter control, right? Like, you're dealing with more ephemeral environments, and so your old methodology of protecting yourself is gone. Now, if you take a look at Kubernetes, to be fair to the project, it's becoming more popular and it's a fairly new project. And so your attack surface is becoming more popular. For example, if Kubernetes wasn't popular, do you think people would attack it? Yeah, yes or no, right? One of the original designers, let's say, of Kubernetes, like as a software engineer, I don't think that my software is going to be used for bad. I just don't. At the back of your mind, you kind of like, we have to have protection. I'm not sure if everybody on the panel remembers the unauthenticated kubeadm vulnerability, probably one of the highest CVEs out there in 2017, 2018, that people were taking advantage of the clustering mechanism. Like, hey, if they're unauthenticated calls, I can just take over this node and all other nodes will follow along. The original designers didn't see that, right? So it's like, as it becomes more popular, it becomes more complicated. This is where having high-level orchestration, can we enforce compliance on one cluster? Can we lay down infrastructure in a certain way? Becomes important. But long-winded answer. Sorry for taking that long.
All right. Well, Sharon, you want to jump in on that? Because one of the things that I have seen is, like, every time I look at these vulnerabilities, it's not always the container or the Kubernetes cluster. It's the host underneath it. It's the entire stack, and somebody's figured out how to come up through, common infrastructure that we already have and kind of push it up to take over the container or try to jailbreak something or whatever. So, are we just overlooking the fundamentals?
No, so I think you have a few levels here. So the first one is to secure your container-based images. This is sort of like the, straightforward one. So the workload inherits everything that comes from the base image that you actually choose to build on. So you should select, minimal base images, add only what you need and not, don't take like the default ones. So this is the first thing, but there are other levels to it. So if you go, up, so there you have to secure your code, you have to secure your dependencies, and it all comes down to what you just said. Because this is a management platform, it's not just my code, it's everything. It's the network, it's my code, it's the dependencies, it's the images. So it's basically everything, and then you have to secure all the layers that you add. So the vulnerabilities, you build up in layers. usually in Docker files. You have to actually uncover the vulnerabilities that you have both in the base image that we discussed, but also in the application. So you can either do that using, CI/CD tools, or do it when you are actually running Kubernetes and monitoring it. So it's basically up to the pipeline that you're running.
Well, I would disagree with just one thing that you said, and I don't think you intended it that way. But you said you can do it, or that there's. But I think it needs to be and, right? You need to be detecting these things before you deploy, and then also in runtime. So you need to have active mechanisms that are constantly scanning, because you don't know what the vulnerability that's going to be uncovered tomorrow might be. So you have to be doing the runtime scanning as well as scanning ahead of time, in the CI/CD pipeline as well. And you have to be able to trace back when something does go wrong, right? So, and this goes back a little bit to the enterprise question, but there are governance teams that are going to demand audits when something goes wrong. And so it just goes to show you, I think it's true that we, as operations teams, certainly throughout history, we tend to leave security to the last minute. This tends to be an afterthought. But it really goes to show you that security has to be in the forefront of our minds as we go through the entire process, as we're developing these new architectures, as we're building these new platforms. Sorry to harp on it so much, but we're just seeing it time and time again, where people come back at the end of the day and they say, oh, I didn't realize that someone gained access to my system and was running all these things and deleting their history. I wish I would have built the system around those concerns to begin with, and then I could have prevented this from happening.
Yeah, I can't agree more with what both of you just said. I mean, we talk about DevOps, and then when they try to make DevSecOps be something different. It's not. Security needs to be part of the developer's job, and they need to be enabled and empowered to participate with security, and not have it be the people at the end of the pipeline that are going to stop my product from getting out to production. So yeah.
Hey, Chad, let's dive into that a little bit, if you don't mind. Are the job functions changing in the enterprise as we make this transition to Kubernetes? Historically, there was, compute guys, storage guys, networking guys, developer guys, security people. Is that all going to meld together? And, is there going to be something who's like, what, super administrator? I don't know. Or are there just too many functions for that, and we just need to figure out how to make everybody kind of collaborate and work a little more closely together, but we'll all have our little swim lanes?
Yeah, I mean, you said a great word, collaborate. And I think that's what a lot of people right now are focusing on. It's not just the technology and the pipelines, but collaborating across teams and, allowing security, to be processed upstream inside your pipelines in an automated fashion, right? And then we have breaking down barriers between developers and your cloud operations folks to understand what they're doing. And so it really is in the DevOps kind of spirit of, collaborating across all of these teams. Will they, meld into one giant team? I doubt it, because people have their certain disciplines and things that, they have to be on the hook for. But we're definitely seeing a more collaborative effort across all of the teams to get code out.
All right, Aaron, you guys bang the drum hard for the melding of security and IT operations, among other things. What do you think?
Yeah, we definitely see that occurring, right? And I think the difference is it's not like the NOCs and the SOCs are going away, but everyone just needs to be more aware. So you used to be able to live in your own bubble, right? You could say, well, I'm responsible for this one thing. I'm just a developer. I don't need to know about the way the system is architected. Well, that's a great goal to have to make your life easier. I think that we're seeing more melding of teams, and everyone needs to be a little bit more aware of how the environment operates, so that they can stem off these problems that could come later on. And I think that's a good thing, to share knowledge, to be more aware. Everybody wants to learn about something new anyway. So, I think it's a good thing to have these teams maybe not coming together, especially as you go up to the enterprise. You'll see there's still these teams that are separated from each other, and that's fine. They have to be because of the complexity of the scale, which is exactly what we're talking about, right? But you do see this kind of cross-pollination where when I'm hiring someone for a DevOps team, I want to make sure that they have some security knowledge. They don't have to be an expert, but I want to make sure they have some security knowledge, have some operations knowledge, and certainly have some knowledge about how Kubernetes runs and works, because when they're writing their code, they can be aware of that, have that in the back of their mind, so that we don't have to go back and correct things later. And all of this leads to speed of development, right? All of these things that we're talking about make it faster for companies to, and more secure for companies to deploy their code. And at the end of the day, a lot of times that's what makes you more competitive.
Yeah, I think it's also a matter of awareness, because I mean, security is everyone's problem. It's not only the security team's problem or the, or the DevOps problem, it's everyone's problem. And I think it's about more of the awareness, other than, it's not the expertise. It's not that each and every one of my developers is going to be a security expert and research CVEs or something like that. It's just that he needs to be aware and have that, as you said, in the back of their mind. They need to have the security concept, well understood.
David, will things get even more challenging? There's this little thing called edge computing starting to happen, and people are talking about pushing Kubernetes all the way out to the edge, and each one of these little clusters might have a single app on it, and there could be maybe one day more workloads running at the edge than there are in the cloud. That's hard to believe, but it's possible, I imagine. Do you think that we need to start preparing for that today, or is it already happening?
I'm not sure when we should start preparing for it, but it's definitely something that I see as much more prominent. Is the concept of smaller Kubernetes clusters and distributing our applications across multiple clusters instead of deploying them onto larger clusters. And really cool projects trying to get Kubernetes to run on Raspberry Pis and distribute them, physically as well. And the minute we do that, the minute we adopt that edge compute model, when we talk about perimeters, like everything changes, because we then have devices, whether they are Arduino boards or Raspberry Pis or whatever, or even just computers, they're not in a data center anymore. And I think the concerns that we have around that are something that I wish I had answers for, and I definitely do not. But yeah, like edge computing and what we're doing with Kubernetes is definitely changing the way that I think about it, even if I've not got a concrete idea about what that means yet.
Well,
so the perimeter going away? Do we no longer have perimeters?
I want to chime in on what David just said. I think that the definition of edge is changing over time as well, right? So you mentioned like Raspberry Pis and Arduinos. Well, you're not going to run Kubernetes on Arduino, but Kubernetes might be Arduino might be an input into that. I mean, I'm running K3S, which is a Rancher project. I think Rancher started it for smaller Kubernetes deployment on this isn't a Raspberry Pi, but it's a similar board. I could go deploy that anywhere. So that's one definition of edge, but also you have customers that are consider their edge to be their point of sales devices in the millions of stores they have across the country, or it could be in a factory, for example, right, where they have a small data center. They consider that edge, and that's much different than just running a Raspberry Pi in the field. So I think that we will start to see Kubernetes migrate out to the edge in various formats over time, because as we start to standardize on Kubernetes for the way that we like to deploy our applications, we're going to need to have that same functionality. We're going to have to see it look and operate the same way, no matter where we're deploying our applications. And that's going to make, because I don't want to have to write a new application or have to control a different type of architecture just because it's sitting across the country somewhere, right? I want to be able to manage that and lock it down the same way I do everywhere else in my environment.
All right, guys, I want to round robin here, just this last question, but the first one is, what's your best advice to people as they kind of go down this path, short of course, visiting your own websites, don't go there, but, and what did you do that, maybe was like the dumbest thing you've ever done with Kubernetes, and telling people not to do that so that they can at least learn something up front? And we'll start with David, since you're on the right-hand corner.
So my biggest piece of advice to people, I mean, I'm going to cheat and kind of throw in 2 half answers. But the first is just, adopt open metrics in the Prometheus exposition format to your application. Start having metrics endpoints and having them consumed, because developers don't always put observability front of their mind when they're deploying their applications. And it's one of the biggest things that's going to come back and bite you on the ass. The second one is to adopt GitOps. Another thing that developers don't put front and center is disaster recovery. And I think Kubernetes is changing the way we think about that as well, and that we don't have to worry about disaster recovery because we have a deployment and a replication controller, and Kubernetes is going to reconcile that state for us. But things do go wrong, and Kubernetes clusters are still in a stage where we maybe have them more like pets than cattle, but ephemeral clusters, smaller clusters using automation like the cluster API will become the norm over time. And we need to, if we using GitOps as a deployment semantic, storing our state of our clusters in Git gives us a lot of benefits with regards to disaster recovery and reproducing environments at scale as well.
All right, Eric, you want to add to that?
Sure. Best advice, I guess I should stick to a security point since that's who pays my bills now. I would say secure supply chain for your software. When you're dealing with containers, you need to know where your container came from and have provenance on it. Especially, we were just talking about edge, and one of the things I've seen at some very large retail and energy companies is they want to put these edge devices out at very high latency distant places, and knowing that the images that are running in the containers on those devices came from the right place and haven't been modified in any way is huge for them. And it's a tough thing to tackle when you have a very slow link. So secure supply chain is my number one.
All right, Aaron, best advice.
Well, David stole my 2 things. I was going to talk about GitOps and Prometheus. So, but I would say it does all come down to standardization and having a plan, right? So we're here today talking about Kubernetes and scale because this is the challenge that companies face right now, right? Is how do they scale? It's easy to get started. What do you do when you have 100,000 containers running out there? So I would say standardize as much as possible, whether that means Prometheus, taking a look at open telemetry for applications, certainly using Kubernetes. The more you can standardize, then the more insight you're going to have into your environment, and the easier it will be for you to shift one way or the other when the need arises. And what I mean by that is, let's say the tool of choice that you're using isn't cutting it right today for some reason. It's a lot easier to shift that tool to another vendor or write your own tool if the system is based on standards. So for as much as we like, our name your favorite tool out there, the more that those tools adhere to a standard way of doing things, the happier you're going to be in the end, because it gives you a lot more freedom to do what you need to do in order to make your business run better.
Great. Sherry, question to you. Best advice.
So I would say, first of all, start small, because there is definitely a learning curve when dealing with these, very, very not easy to learn applications. So that's my first thing. And my second is, of course, don't neglect security. So Eric just mentioned, supply chain security, but in addition to that, upgrade your open source components. Make sure that your open source components, specifically Kubernetes, but if you're running any open source on top of Kubernetes, make sure to have the latest version. This will definitely keep you from, having security risks in your application. So that would be my number one advice.
All right, great. Guys, we're running out of time, I'm afraid, so I'm going to have to skip the last 2, but I'm sure a lot of you guys would probably say many of the same things. Our Amazon gift card winners are Wendy H., Robert P., James M., David B. I want to thank all our experts for sharing their knowledge today. It's been a great event. I learned a lot, and best of all, you all are now armed with opportunities and knowledge you didn't have before, so you won't make the same mistakes they did. Thank you all for paying attention, and best of luck.
Thanks, everybody.
Bye, y'all.
Bye-bye.
Thank you.
Bye, thanks.